So it's been a while. I mentioned a couple videos ago that I was going to be very busy for work, and I have been, and I'm going to be for a little bit longer. But spring has arrived, and that means that I'm really on the clock now for getting the boat in the water, and I have a lot to do. I'm going to go into more of this later, but I have now ordered everything I need to prep the propeller. I have the 5 kilowatt motor on order, and I have the second motor controller on order. When they come in, I'll make videos about them. But those are relevant because of how the Helm control has been evolving. I think 3 or 4 times I sat down to make a video about how the STM32 based Helm control was coming along, and none of them worked out. I was really struggling to get through that vertical learning curve of the STM32, but it's been worth the effort. So one of the first things you might notice is that I now have 4 DACs instead of 2. The reason for that is, from the same Helm control, I want to be able to drive either the 10 kilowatt motor or the 5 kilowatt motor using the same Helm control. I'll go into more in detail momentarily on how that's working, but these MCP 4725 DACs, they've got a pad on the back. Normally when you get them, their address is 0x62. If you short that pin, you get 0x63. So I have 2 I2C buses on the STM32. One is going to drive the LCD, which is not working yet and won't be for a bit, and the other is for driving the DACs. When I was driving this from the Arduino, which only has one I2C bus, I was only powering the one motor, the motor and the regen, so I only needed 2 DACs and that was fine. If I didn't want to use the STM32, I could have just used 2 Arduinos and, I don't know, had to switch for the throttles or something. There was other ways to solve it that would have been simpler. But again, I've really wanted to learn embedded development for a very long time, and this has proved to be a very useful project to learn that. So I'm sure some people are going to be like, but why did you put so much time into this? Honestly, the biggest answer is I just wanted to. It's something I've always wanted to learn. And oh boy, have I been learning. So originally I was going to say, well, I've got 2 I2C buses. I'll have the 10 kilowatt throttle on, the first bus, address 62, and I'd put the 10K regen on the first bus, 63. And then I would put the 5 kilowatt throttle and regen onto 62 and 63 on the second DAC. Originally I thought that would be okay because the LCD here, it can be programmed to have a whole array of different addresses. So I thought, okay, well, I'd put the 2 DACs on the 2 buses and I'd put the LCDs, right now I've only got the 1, but down the road I want to have 3 or 4 of them on the same bus as the DAC. And I was speaking to Andrew this morning and he was like, that's not really a good idea because the LCDs run at a different speed than the DACs do. So he helped me understand how to solve this problem, which I'm working on right now. Instead of shorting the jumper on the bottom, I'll put a picture here. Instead of shorting that to change it to 63 permanently, you leave them all at 62, and then you run a digital out pin from the STM to the address 0 pin of all of the DACs. And what that means is that you drive them all high, which takes all of the DACs and runs them up to 0x63 at the same time. And then whichever DAC I want to talk to, I deassert? I send 0 to the pin that goes to that particular DAC. It drops it down to address 62. I talk to it, and then I pump it back up to 63. I go to the next pin, pull it down, which changes the address to 62, leaving all 3 of the others on 63, write to it, and so forth. And in this way, I could have an unlimited number of DACs on the same I2C bus. So that's a really fancy way of saying I've solved the problem of being able to control 2 different KLD controllers off the same I2C bus. Now, I could have also done that with the Arduino, but the Arduino has far less pins than the STM32, which is one of the reasons I wanted to switch to it as well. So now that I can control all 4 DACs, throttle and regen for the 10 kilowatt controller, throttle and regen for the 5 kilowatt controller, the last thing I needed to do was just add a simple toggle switch. I have a switch that when it's not closed, says so the default is to run the 10 kilowatt motor. But if I flip that switch, it tells the controller, I want to control the 5 kilowatt motor, and it just decides then which DACs am I talking to from inside the software. The other thing I wanted to do was have two throttles. One of the conversations that came up quite often in the video where I first got the motor spinning was, what happens if this fails? And a lot of people were suggesting going to, I can't remember what the proper term is right now, but the magnetic-driven pot, which I still might do down the road, but not this year. Originally, I was going to just make two throttles and have one in a box somewhere so that if my main one died, I could just unplug it and plug the new one in. But of course, Murphy being Murphy, the throttle was going to die at the most important time possible. So, while pondering this, I came up with an idea. Now, I haven't shown the dashboard I'm planning to make for the Helm controls yet, but it's going to be basically a wide, slightly thick box. And I was going to put the throttle on one side, on the starboard side for my right hand, because I'm right-handed. I thought, why don't you just add a second throttle on the port side? So facing forward on the left-hand side. This way, first of all, if anybody wants to helm my boat who happens to be left-handed, they could just use the left-handed throttle. And for people like me who are right-handed, I could use my right hand. And there would just simply be a select switch that would select between, do we want to use the starboard throttle or the port throttle? So on top of being friendlier to left-handed people, what this also means is that if one of the throttles starts to act up, all I have to do is flip the switch, it's immediately ignored, and start using the other throttle. So I have two throttles, and I have two motors and motor controllers, one brain. So I could select, for example, the starboard throttle and the 10 kilowatt motor, and it goes through like this. Where if I wanted to switch to the 5 kilowatt motor but still use the starboard throttle, it goes like that. Similarly, if I go to the port throttle, to the 10 kilowatt, it does that. And if I go to the 5 kilowatt, it does that. I know that doesn't sound very fancy, and it's not, let's be very clear. But it's far more than I could have done on the limited memory available on the Arduino. When I was writing the Arduino software, Sketch is what they call it, I was noticing that I was already coming up on the limit of how much memory was available for programming it. Even with just the simple single pair of DACs for throttle and regen and one throttle input, I was getting close to the limit of what I could program into this. If you recall, I think I included it in the video, but maybe I didn't. I took the Sketch and I tried loading it onto the ESP32 and it worked. And then I tried loading it onto the STM32 board, the Nucleo. For anyone playing at home, it is the Nucleo F030R8. It said there wasn't enough memory. And at the time I thought, okay, well, I'm going to need a bigger board. And Andrew was like, no, you don't. It's got plenty. And I thought, if I'm already close to running out of space on the Arduino, and I want to add a lot more features, how the hell am I going to do it on the STM32? Well, this is one of the huge things I've learned. The Arduino, I am convinced now, is basically magic. The amount of complexity that Arduino IDE, you saw me programming it in, it had the serial display at the bottom. The amount of complexity that hides is staggering, like shockingly amazing. I can't even think of the right adjectives to describe how much the Arduino lowers the barrier to entry for developing boards. As I speak about the reasons why I switched to STM32, in the process of learning about the STM32, my appreciation for and respect for the Arduino has just gone through the roof. To make that level of simplicity work, a lot of stuff has to be compiled into the sketches that are loaded onto the Arduino board, and that eats up a lot of memory. The STM32 requires you to go through and define all of the pins yourself. Actually, let me show you. You're probably going to look at the back of my head, I'm afraid, but I can use this space to put what's there up here. So for example, one of the first things you have to do, and this is all wired up, so I can't show you the actual board at the moment because it comes apart fairly easily, which is going to be a problem when I go to test the board. But anyways, one of the things you have to do is you have to first sit down. Actually, let me show you the Arduino code. This is a different editor than I was using with the Arduino IDE, but the code is here and it's syntax highlighted. So you can see, for example, all I had to do is I just said, throttle stop switch is 12. That's it. That's all I had to do. And there's a set of pins on the Arduino, and you just simply say, I want 12, and that's it, and you get 12. There's nothing more to it than that. It's dead simple. And to write to one of the pins, all you do is digital write, which pin you're talking about, and the value you want it to be set to. Similarly, for reading the switches above, I do an analog read for the DACs, or for the potentiometers, and I do a digital read for the switches. It's ridiculously simple. That's it. That's all there is to it. Let's look at how we set this up on the STM32 now. So on the STM32, you start off with this chip with all of the pins undefined. So the very first thing I have to do, let's look at, for example, the main switch. I think I called it the throttle stop switch because I changed a bit of logic. I don't want to get into it right now, but I simply say throttle stop switch. I read that pin, set it into a value, and that's it. I'm done. I can use that value now. It's going to be 0 or 1, and I use it. Here, I first have to come in and I have to tag it as being a GPIO input pin, and then I give it a name, and then I come up into the GPIO settings here. What was that? That was, so this is the other thing with the STM32. You have banks of pins. Instead of being able to say pin 1 through however many pins you have a port, like port A, which then has a bunch of pins on it. So you have like PA1, PA4, PA7, and that means it's port A, pin 7. So you have these banks, PA, PB, PC, PD. I'm trying not to get too deep into this, but this is part of the learning process. But anyways, we're getting back to it. PA4, I come over, I've set it to, it's a GPIO, so general purpose input output. And I look for PA4, and I see that it's set to input mode with a pull-up resistor. Pull up, pull down, no pull up, pull down. You don't have to think about any of this with the Arduino, it just works. Whereas if I want to read a potentiometer, for example, over in the Arduino world, if I want to look at the pot, for example, throttle pot, throttle input, I do an analog read, and it gives me a value between 0 and 255. And that's it. I'm done. It's an 8-bit DAC. These have 12-bit DACs, so much more granularity. But let's get back to this. Here, if I want to read a pot, so for example, here's my starboard throttle pot, PA0, I have to say it's a GPIO analog pin, and then I go to PA1. Oh, that's the other thing. DMA. I'm going to be reading from 3 pots, because I got the regen pot, regardless of which throttle is actively active, because regen's not critical. And then I have 2 throttle pots. So I have 3 pots that I could be reading, which I'm currently showing as 1 pot, 2 pot, 3 pot. So this is port throttle, or starboard throttle. This is port throttle, and this is the regen setting. One of the things the Arduino does, which makes it really easy to read, is it interrupts the CPU and says, hey, please go read the value of that potentiometer. It reads it, and it comes back and it does its thing, which, again, makes it very easy to use, but it takes a lot of processing power away from the CPU. Here, it's now set up to use DMA. So behind the scenes, the pots are being read and recorded into memory space constantly. And then for the processor, when I want to actually read it, I was showing the setup of the pin. I'll be right back to that. Coming to the code, first of all, you only have 1 file in Arduino. Here, you have many, many files in many different directories because everything has to get set up. But there's no hand-holding here whatsoever, which is it is the downside and it is the upside. It's the downside because the learning curve is much steeper, but the upside is that you can make your programs far more efficient and therefore fit into a smaller space and be faster. So one of the things I want to do is, in order to read the DACs, I don't actually ask the processor, hey, please go check the value of that DAC. There's a background process that's just constantly, DMA is direct memory access. So the potentiometer its value is being read into memory constantly behind the scenes without the CPU needing to do anything. So when it comes time for the CPU to want to see the value, it just reads RAM. It doesn't have to go out and actually do anything. It's just reading RAM. So it's much quicker and much easier on the CPU. Oh yeah, we haven't got into the init yet. This is not going to be a very good introduction to STM32, and that's not really the purpose. I just try to give you an idea of why I've been missing in action lately as I've been learning all of this. So I have this function called IO control get pot, get potentiometer. There it is. It's defined in here. This function literally just goes to the, it takes in a channel. Wow, how do I get... trying to think of right now how to get across the complexity and the power of STM32 without turning this into a 3-hour video and being boring as hell. This is what I've been struggling with the last few times I've tried to make videos, is there's so much here, and there's so many videos out there already that do a much better job than I can possibly do at explaining this, especially because I'm still new to all of this, so I'm not entirely confident in what I'm even saying is right. The fundamental function of the STM32 is the same as the Arduino. I think that's what really matters here, except all of the hand-holding that makes the Arduino so easy to use is gone. But that means the overhead of the Arduino is also gone. So where I could not load the basic sketch I had written in my early video onto here because there wasn't enough space, I am now doing dramatically more, and I still have lots of space to play with. I think this has got 64 KB, and yeah, everything here is 20 kilobytes. I am doing dramatically more work. Everything together, it's 20 kilobytes. Like, the efficiency of STM32 is staggering. So I've got this little, really narrow screen that I've been using, and I plan to use this on the boat inside at the nav station. There's a little bar across there. I don't want to ruin the 80s aesthetic up on the helm, so that'll be kind of hidden. I was going to try to record that with the on-screen, but that seems to be a problem. Oh, I should mention, one of the other things that Arduino makes great is that the serial data coming from the Arduino is just shown on screen. You don't have to think about it. With the Arduino, I actually have to figure out what the serial port is and use a terminal program, in this case I'm using Screen, to connect at a known baud rate, 38,400 baud. Again, something you just don't have to think about with Arduino. But when I do that, there's the actual connection. One of the things I wanted to do was add, and this is what I'm eventually going to have printing out on the LCD display, shorter versions because I only have 16 characters by 2 rows, but I wanted to add a selection switch. So I'm going to have probably 2 or 3 of these LCDs. Each one's going to have its own selection switch, and I can decide what information, or whoever's at the helm can decide what information they want displayed on their 2 or 3 LCDs. And they choose it with a selector switch. Now, these are not momentary contact. I have momentary contact versions of these on order, but I had to order them, and I guess they had to make them, and because I only ordered 10, the current estimated delivery is now sometime in September. So the boat will be going in with non-momentary contact, but I'll have them for next season. So, each one of these pages, you'll notice the 16, 17, 18, that's just to show me that it's actually printing data to the screen. So this shows the switch state, shows me the throttle state. So if I go to the throttle, is this it? I don't know what that is. I haven't labeled my switches yet. Ah, this is going to be the throttle select. Or not. Now, I've also done a whole lot of changes, and it's entirely likely I could have broken something. One of these is supposed to... Ah, this is the motor selection switch. So, it's a 3-way switch, and the reason it's a 3-way switch is, I mentioned earlier that I'm going to have a starboard throttle, a port throttle, but in the future I want to have a middle position where neither actual throttle's in use and a remote is in use. So I could be like at the helm and control the throttle over a wireless connection at the, you know, if I'm messing with the anchor or whatnot. But for now, if you go into the middle position, middle position will always default to the starboard. And then with that, I've got my ramping working. I still have to dial in some of the values. And I don't even know if these are working yet because the output voltages of these, because I just made a whole bunch of change to the code. But you can see I've got the percentages working. I've got the ramping working. And Starboard throttle to 10 kilowatt motor. And now I can set the regen if I want. Oops, I seem to have broken the regen. Hello? Okay, well, I'll figure that out later. I just did a whole bunch of rewiring, so it's not surprised that I knocked the pins out, but normally that would be the regen would be changing here. Anyways, back to it. That's just the switch states. Actually, I can show you the switch states. I need to debounce this. Okay, there we go. So I have my main switch. The main switch here is not going to be the e-stop. That's simply going to turn off all of the lights on the helm. So if you're sailing at night and you want to completely dark out the helm, you can flip this. The helm will go dark, but you'll still have full control. The e-stop is this one. So there's going to be a dedicated e-stop. This shuts the motor down no matter what, but it leaves the helm up and running. I have got, what is this? This selects the what is this? I built this. This selects the 5 kilowatt motor. No, there it goes. So the 5 kilowatt motor is now selected. Flip off. It's not selected. That's how I'm going to choose which pair of DACs are being signaled. And what is this again? This is the speed. So you can see the speed, high, neutral, low. So I've got a page that's going to show the switches. There's the showing the speed. So this one here is more useful for when it's going to be on the LCD, so you can see if you're in high, medium, or slow speed. Regen, relative throttle positions in percentage, or throttle and regen positions in percentage. So you can see right now it's in forward. I dial back, I go to neutral, and then I'm in reverse. Same as we had before. That is a throttle selection, and it shows the raw, clean, and smoothed values and the output value to the DAC. Same thing for regen. And there you go. So what I'm going to start testing here in a moment, I hope I'm going to make this video not boring. Anyways, I'm going to have the voltage output for the 10 kilowatt throttle. We're going to have to test that. There's a couple things I need to test. First of all, does it even work after I've made the changes where you have the address pin? And second, once it is working, now that I've got the 4 DACs I'm going to use on the boat, each DAC is slightly off as to which value gives me 2.5 volt, 0.05 volt, and 4.95 volt, which are the limits. If you recall, when I was configuring the Cali controller, if it sees a voltage drop below 0.05, it thinks that the cable's been disconnected. And if it sees a voltage above 4.95, it thinks there's a short somewhere, and it's getting 5 volt right in. So the range has to stay between 0.05 and 4.95. So I need to figure out what digital value do I send to the DACs to stay within that range. And when I'm in the neutral zone, I want it to snap to 2.5 volt for as long as I'm in neutral. Oh, one other thing about the DACs while I'm thinking of it. This was brought up by Andrew when I was talking to him earlier today. With the DAC on the Arduino, I believe I was writing to the EEPROM all the time. If the DAC lost power and then powered back up, by having the value written to the EEPROM, when it powers back up, it goes right back to the same setting. That sounds like a good idea at first, but there's actually 2 problems with that. The first is that the EEPROM has a limited number of writes, after which it dies. It's going to be something like 1 million cycles, but when you consider it's looping, you know, every 10th of a second, it's not going to take long to hit 1 million and kill the EEPROM. So I don't want to write to the EEPROM, and I don't know if I could actually control that with the Arduino. I might have been able to, but I didn't see it. You can write to a different address and it just sets the value. So one of the things I'm going to be doing is once I dial in what the throttle DAC is for the 10K and 5K to be at 2.5, when the controller boots up, when you first apply power to it, it's going to write to the EEPROM to say, set yourself to the neutral position, 2.5 volts. And then once it goes into operation, it's only writing to the live memory, which doesn't do an EEPROM write. What that means is that if I ever lose power to the helm while the throttle was at like a high throttle position, when it powers back up, it doesn't try to instantly command high power again at the propeller, at the motor. So it's going to have the EEPROM set to a safe position, and then we're going to work with the live memory only from that point forward. I said there was 2 things. That was one, the EEPROM writes. What was the other one? I will drink coffee to reboot my brain. I can't remember. It'll come back to me. I need to get the DACs working, and now that I know I've somehow messed this up, I need to trace my wiring to get that sorted. Oh, and I should mention before anyone asks, this jumble of wires is not what's going on the boat. Eventually I want to actually have a dedicated circuit board made so that the STM32 and the DACs and everything are all on a single circuit board. I've actually already had someone, company message me offering to sponsor PCBs. It's not PCB Way. I know they sponsor a lot of people. There's another company like them. I'm not taking them up on it yet, but when it comes time for me to make my PCBs, I might, especially because I'm probably going to screw it up a few times before I get it right. And I will be releasing the source code. It's already up on GitHub. I will also release all of the designs for the circuit boards as I develop them. But these are what are called proto boards, prototyping boards. And I have a whole bunch of different ones in different sizes that I ordered last time I got an order from DigiKey. And I am going to be taking this jumble of wires and getting rid of most of them to a circuit board. And for the ones that don't, where I have the biggest problem is I have these loose wires that just press fit into the PCB. They love to pop out all the time. Can I get that? I feel pretty comfortable now making these jumper wires. And I'll do a little video showing how I do it now that I've learned, because I couldn't find a good video to teach me when I was trying to learn. But I will have a bunch of these that will go from header to header, so at least where I do have to come off of the STM proto board to my board, most of it will be soldered in, and what isn't is going to have a nice firm connection with these wires. In fact, I have a bunch of these polarized headers so that I can solder these onto the proto board and then make a wire with this header on it, so it actually, first of all, I can't put it in backwards, and second of all, it latches it into place. I've set a goal for myself, possibly unrealistic, to be in the water in 2 months. I'm not going to have the circuit boards done in that period of time, but I want to at least have a more durable proto board by the time I go in the water. Also, insurance is still not sorted out, so yay. I've got to do some more debugging with this. I actually also have some day job work I have to do. Yay, Saturday work. I'm going to turn off the camera. Back in a bit. All right, day job done. I am going to try to debug what I did, and in the process of doing that, explaining how this works. Also, after many years of faithful service, this broke. So I called I emailed BK Precision, and they're charging me $10 for a new back plate. So it's got the stand and the back cover, which is not bad, considering it's like a $180 multimeter. I mean, today, it's not what I paid for it back in the day, inflation being what it is. So I'm just going to let this play as I try to debug it. So the first thing I need to do is make sure that I am on the 10 kilowatt motor, which I can see right here I am. Out 45 to, okay, so I got some bugs with the regen, but I'll come back to that later. Let's go to the, why is the 5K motor not working? Okay, this was working. Did I knock something out? Oh, that's the throttle select. Oopsie. I should put like little stickers on these or something because I keep screwing that up. That's my motor select, I think. There we go. Okay. Why does it think it's forward 20%? Am I using the wrong DAC? Yes, I am. This is the port input, so I want throttle and neutral. There we go. Set this to voltage display, and right now it is showing 2.574. Now, let's see, is this working? No. Honestly, I would have been a little surprised if it worked right off the bat. All right, let's get to the page where I see the actual pot values. The output is listed at 270 currently. All right, so I can see the output has changed to 2276. So let's check the voltage of the address pin. It's currently 3 volt. You know, this is a job for the meter. So I just bought this, and I have never owned a wiggle scope before, and I am still very much a beginner when it comes to using it. I know that I need a ground pin. I'll connect this. And I'm going to say auto. I think those are the drops. How do I... Oh, I'm seeing it jump between 0.5 and 3. Why is it doing that? So normally it's high, it drops low, sends data, and then comes back up again. So it looks like the signaling is working. Okay, as soon as I plugged it in, it went to 2.5 volt. See, the thing with the meter is it shows you just whatever voltage it's seeing at the moment. So if it's dropping really quickly, you're not going to see it. This records over time, so you can see the pulses. So I wonder if the voltage is consistently 2.5 volt or if it's changing and popping back up again. Like I said, I really don't know how to use this yet. I'm still learning. Yeah, nothing's changing. What I need to do is sample this while it's also feeding data to the DAC instead of pulling it off the DAC. I shall put this back on the output voltage. It's 2.5 volts as expected. Okay, so now it's sending 35, 36. So this should be 3 or 4 volts. And again, I can see the signal dropping and popping back up again. If I change this delay to 10 milliseconds, the idea here is I am setting the address pin to low, which should change the address to 63. I wonder if I've got that backwards. I'm going to flip this around and say, okay, change one thing at a time. I'm going to leave the delay at 1 millisecond because Andrew said that should be enough. I will go into my my main.h file, addresses. Let me invert the addresses. What is going on here? I have many problems, but that's expected. I am going to /* come all the way to the bottom, do //. Why did that not comment everything out? Oh, because it put the close on it right away. Okay, so that comments out everything. What I want to do is just write to one DAC and one DAC only. So I'm going to take the 10 kilowatt throttle DAC, I'm going to copy it out of here, and I'm going to put it here. So regardless of what the logic is, it's always going to write to this DAC. So now if I do that, and I run it again, what do I get? 0 volts. Okay, so I'm looking at the right line, and I see that for sure it's sending out 3619, but it's gone down to 0 volt. Okay, so let's try changing this to common. There it is. Okay, so there it goes. Okay, so the throttle's working now. Now, if that's the case, then what I am probably doing wrong is I'm going to set this back to the active, and I want to invert the logic so that 1, 0. The idea behind these defines is that when you're writing in C especially, it can be very easy to lose sense of what an individual digit value might be. So by assigning a string to it, it really just makes the code easier to read. When it goes to compile it, it just fills all these in and compiles it as if you didn't have this variable. So this variable is literally just there to make your life easier. So take the M10KW throttle DAC address 0 pin, set it to be address 0x63, wait for 1 millisecond to make sure it's had time to come up, set up the data that I'm sending to the DAC over the I2C bus, send it to the I2C bus, and then set it back to address 62. Okay, so if that's the case, now let's see if this works. Or if I got this backwards again. Okay, this was working. Why is this not working anymore? I'm not seeing it do that. It's not working at all anymore. What the hell? Okay, so now I'm sending 1235. I'm going to take the variable out again. What the hell's going on? It was working before. This is what it's been like all along. Active is 0x62. Did I get that backwards? Oh, now it's working. Okay, so one of the things I'm doing at the beginning, before I come into the infinite while loop, is I set all of the pins to 1. I gotta remember what I was talking to Andrew about. I've opened the address line, so all the DACs are now 6.2 by default. I will add 4 GPI output pins, no pull on them. Wire them to A0 on the DACs and default to 1, which should pull all the DACs to 063, right? And then send 0 to bring the DAC down to 6.2 and write to 6.2. So I'm setting them all to 6.3. So I come down here now when I'm ready to write to it, set it to 6.2, do my work, and then set it back to 6.3. Okay, so that should now be working. Okay, it is working. So what I'm doing here is, in this particular case, if the 5 kilowatt motor is selected, I pass the 5 kilowatt DAC value to the appropriate DAC, then I set the 10K to neutral, and then I go and set the regen. So if I switch motors, it switches the unused motor to neutral. Okay, in theory, this should now work across the board, but I'm somewhat skeptical to believe that it will. No, same thing, it's dropping back out. Are my delays not long enough? I can see the address pin being pulled low. What is going on here? Okay, let's simplify things. Let's take this out. So the one that was working, I'm using the same port and the same pin. What is going on here? So the only call to the DAC now is here. Bam! 3.4 volts. 4 volts. Okay, so I've re-enabled everything in here. If the 5K motor is selected, that should have no impact on this. If it does, then I don't know what is going on. Okay, it looks like it's working. It is working. Okay. So now I can ignore this chunk of code up here. Do I have this backwards by chance? I have them backwards. Okay. So one of the things Andrew showed me to do to make my life easier is to document everything in tables. This DAC on the black cable should be going to here. So if I come over to here, oh yeah, okay, so the regen is supposed to be the black cable, but it is currently getting the signal for what should be the white cable. So PB9, the white cable should be PB8. So if I come over to here, PB8 is throttle DAC A0, PB9 is 5K regen DAC. It's supposed to be white, so it should be white and black. And it is white and black. Let me see if I can show you that. So you see how there's one pin there, so that is going to be CN10, pin 3, and pin 5. Should go to PB8 and PB9. So is PB8 CN103? Is that what I got wrong? PB8 is CN103. PB9 is CN105. 8, 9, 3, 5. So where did I get this wrong? So you can see it goes white, black. Oh. I see what I did wrong. Yeah, that's going to the 10 kilowatt motor. That's why things were all screwed up on me. I am certain that someone's just looking at this and like, Maddie, you're doing this wrong. Maddie, you're doing this wrong. And I am completely missing it. This is what happens when I've been staring at this far too many hours. Okay. PB9 is CN105. I want to get all the data into one place because bouncing back and forth, I was getting confused. So CN7, 1 and 3 is white at the top, black at the bottom for the 10K. CN10 is, so it goes white and black. Okay, yes, these are backwards for sure. All right. I'm not writing to the DAC, so that might be why that's not updating. Okay, one thing at a time. Let's come back and make sure my throttle is still working. All right, so now what I need to do is come back up to my definitions and make sure these are still correct. The 10 kilowatt throttle pin is on C10. Regen is PC12, channel C. Well, PC12. The 5 kilowatt is PB8. So there's throttle is PB8, port B, pin 9 for the regen. So these names are all accurate again. So the question is, how is this working at all? It shouldn't have been. Unless I was inverting the logic and it was... Okay. Because all of them are supposed to be on 63, except for the one I want to talk to is 62. If I got that flipped, that might be why it looked like it was working. Okay. All right, so that's working. Now if I come over to here, this should now be 2.5 volts. And it is. And the regen DAC should be 0, but I don't think I'm setting it yet. Oops, that's pushing it to the ground. Yeah, that's also 2.5 volts. Okay, so now that I think I've got it working, let's come back into main.c. Originally I was only setting the 10K and I didn't care about the 5K, but for the sake of debugging, I am going to write to both the 10K DAC and the 5K DAC. But what I'll do is I'll set the 5K DAC to, the 10K DAC to a real value and the 5K DAC to 0 all the time, which I should then see this reset to 0. Oh, that just turned off. That's fine. I'm not using that anymore. Okay. So now the 10K DAC, the regen 10K DAC should be set to a real value and the 5K should be set to its minimum value. Again, I can't go to 0 because I can't set the regen just to 0 because then the Kelly controller thinks that the connection's been disabled. So I've got the minimum variable that contains the value that sets it to just above 0.05, which is effectively off. So now, if this works, I should be able to manipulate the 10K throttle and regen, and the 5K should go to 2.5 on the throttle and almost 0 on the regen. And I've got this watching currently the regen pot for the 5kW, which should immediately drop to 0 once I reload. Bam, 0.056, just slightly above 0.5. That's perfect. That's exactly what I wanted. Okay, now the 5K throttle should be 2.5 volts, and it is. And now regen pot, I don't know what the regen is currently set to, but this should now be manipulatable. And it's not. Damn. Why is that not working? Let's switch this over to the regen. Oh yeah, regen 16, 19%. Okay, I've got a slight problem there. Okay, so the pot is working, but the output is always 0. Okay, so I've got a bug somewhere where I translate the pot value into the DAC value. Oh, because I'm setting the 5K instead of the 10K. That's why it's broken. Okay, this should fix it. Okay, and now I see 4.9 volts. Perfect. And there goes the regen down. Okay, so the regen is working now. Make sure that the 5K is still at 0. It is. Make sure that the throttle on the 5K is still 2.5. See, I've got to tune that. It's 2.58, so that's too close. But that'll be calibrating the pots once I'm all done. And then the throttle. Okay, I think I got it. This is the kind of thing I've been doing more or less constantly. So that was just a little bit of debugging the DACs. I am absolutely not even close to qualified to showing you how to do any of this, but the whole point of the channel has been to show the process of learning, and this is what it's been like. I hope that by showing a little bit of that debugging, you can see how the code kind of works together, how you got the defines where you set what values are what, blah, 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 blah. It's a lot more complicated than the Arduino. For me, I need to get some work done. For you, all right, it is the next day. So let's now calibrate the DACs. We're going to do this by first choosing the 10 kilowatt motor, and we'll play with the throttle. We're going to see what's the highest value we can get out of the DAC. How am I going to do this? Why don't we just start doing it? You can watch as I figure it out myself. Oh, right, I have to turn on the board first. Okay. So starburst select. Now what I need to do is get the multimeter. Okay, so the first thing we're going to calibrate is the 10 kilowatt throttle. So what I want to do is, it's at 2.5 volts. Wow! Be nice when that stand comes in. So let's get this all the way to max throttle. So it's past the, oh, see, it's 5 volts. That's too high. I need to calibrate this so that it doesn't go above 4.95 volts, which again is the Kelly controller's, anything above that, it treats as a short and considers the throttle to no longer be functional. So we're going to go into the, what is it, the main.h header file. And I have got, here we go. So the 10 kilowatt forward fastest is currently being set to 4090, which I can see coming out the bottom here. So that's clearly too high. There's probably some math way to do this, but so with the throttle in max position, 5.035. It's sending 4070. That's not even close to enough. Again, I know there's got to be a better way of doing this, but I just feel like doing it this way. What I should really need to do is figure out how many volts it's jumping per step, and then I could just do the math to figure out 4.95 divided by that many steps. Why is it still sending 4070? Oh, because I was changing the midpoint. Oops. 4.985. We're getting closer. Let's just try an even 4,000 and see what that does. 4.943. And I want to be under 4.94. Or no, sorry, I want to be under 4.95. That's 4.94. Question is, how much do I trust the calibration on this? Let's bring it down a little bit further. If I'm going full speed, it's because I need all the power, which should be very rarely, but the last thing I want to have is the motor cutting out because the controller thinks that there's a dead short. .8, it's probably a little bit low, but let's do 3950. You can tell this is inaccurate science, isn't it? 4.88. I'd like to get to 4.9 even. I think 0.05 volt is enough. Let's try 75. 4.91. I'm happy with that number. Okay, now let's bring it to the neutral. And I want this to be sitting at 2.5 volts on the nose. So it's 2.56 right now. So let's bring the midpoint down. Let's see, 2040. See how that works? At 2.6, anything between 2.6 and 2.4, the controller interprets as neutral. So this is fine. This would work. But I would rather get it as close to the center as I could. 2525. I mean, that's realistically fine. But let's get it down. Let's try 2030. 2.51, let's try 2020. 2.499, I like that, that's good. Now min is full reverse, and I'm seeing 45, and I want this to be 0.05 or higher, it's 0.06. I don't think I'm ever going to go full in reverse. So let's try setting that to 75. 0.09. I'm happy with that. Okay, so the 10 kilowatt throttle DAC is now dialed in. Now I should be able to flip over the motor select. Which one was the motor? Was this the motor select? Yes, that's a 5 kilowatt motor, which means this should always be 2.5 anyway. And I got to come over to this DAC. All right, and I'm getting 2.57. Again, I want to dial that back. I'm going to use my other DAC as a guide, and I'm going to try 2020, because that's what worked for the other one. Now each DAC is going to be slightly different because of the tolerances of the resistors and blah, blah, blah. 2.51. That's probably fine, but let's try 2010. 2.502. I am happy with that. Okay, full throttle. Too high voltage, 5.079. So same thing, I had 4090, let's try 3975 and see how close that gets me. 4.94. So I'd like to get a little bit lower than that on this one. So let's try 50. Yeah, 4.91. I can live with that. Okay, and full reverse. I had this set to 45 and it's 0.59. So that's probably fine again, but I'm going to try 75 also. 0.097. I am happy with that. Okay, so now let's get the regen. These don't have that midpoint, obviously, because it's a regen strength thingy. And it's also not as safety critical, but still going to pretend like it is. Okay, so right now, oh, I need to change the page to the regen page. Oh, so you notice the digit here, the 1 counting up to 255 and cycling. I think I mentioned it earlier, but in case I didn't, that's just to show me that what I'm seeing, if it's not changing, is it not changing because it's froze, or is it not changing because the values aren't changing? This will always be changing. So now, regen is down to 0. And at 45, I'm getting 0.06, which for regen, I might have to play with this when I've got the motor controller going because I need to make sure that that's the point where it completely turns it off. So because I'm going to play with this when I get the controller set back up, I'm going to call that fine for now. Max, yoink. So the max it's reading is 4033 and out is 4090, which gives me a voltage of 5.08. So that's too high. Okay, and we're on the 5 kilowatt right now. So the 5 kilowatt minimum was okay, maximum, let's dial it back to 3975 and see what that looks like. 4.96. That's fine. Again, I'm going to be playing with the DAC values more later, so it's under 3. No, it's not. It's too high. It's not fine. It's absolutely not fine. I need to go lower. Let's try 3950. 4.93. Okay, that's good enough. So now, switch over from the 5K to the 10K motor. I love it when it works. It's so yee. God, once this is working, I'm going to be so unhappy. But not this episode. That'll be next episode. Okay, what am I doing? Right. Calibrating the regen DAC. Same thing, it's too high, set to maximum currently, so let's try the same default values. 3950 on that for the max. 4.90. That's probably fine, but let's bring it up a little bit. Let's try this one at 3975. Now, one of the things, if I was much more ambitious and had a lot more time to put into this, would be to take the output voltage and feed it back in on some other pins so I could read the voltage and then auto-calibrate if I was doing this for a more professional product or maybe even for a future version. I will do that, but for now, it's a manual calibration. 4.925. Yeah, you know what, that's good enough. Okay, so we're done. I don't expect this was probably the most entertaining video, but I think I'm going to end it here. Like I said earlier in the video, I had really struggled with this video, and it's one of the reasons it's been delayed because it's just been me learning, and it's kind of hard to show that on video. I have done, in the meantime, a lot of work on the propeller, but I want to make that its own video. Maybe next? Probably not. I've got more work travel coming up, and I've got a bunch of parts coming in. I'll get that done as soon as I can. As I sit here right now, it is May 5. I want to be in the water early enough that I can get a lot of testing in, and that's May, June, July, August, September at the latest. I'm very, 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 very much feeling the pressure to get the boat in the water, and that's a lot of things to get done. To that end, I want to say a huge, huge thank you to my patrons. Since I started the Patreon, I've only cashed out twice. The first time, there was just enough in there to purchase the 10 kilowatt motor and the motor controller for it, and I think also the contactor and a few other miscellaneous parts. Since then, I've been letting it build up again. I'm trying to make sure that all of the Patreon money that comes in goes right back into this project. I mean, the fact that people are willing to support me, it just blows my mind. Into everybody, I know different people are in different financial situations. To somebody, you know, doing $10 a month, that might be a huge thing for them. It might be pocket change. For other people, $1 a month might be a big ask from them. And I try to always be mindful that it's the support that is so important to me, and just the moral support that people like this enough, like my project enough, that they're willing to support me. So I want to show respect for that. And up on the Patreon, I just made a post where I showed in detail what all the money went through for cashing out the second time. And that is, I have ordered the 5 kilowatt motor, the 5 kilowatt controller. I have ordered the contactor. I went through ABYC standards to figure out what gauge wire I needed and ordered the appropriate ring terminals. I have not ordered the wire yet, but I will soon. I need to figure out how long I think I need. I have ordered prop speed and epoxy filler, though I'm still waiting for prop speed to confirm yes or no whether I can use the epoxy and it'll bond to it. If not, I'll just leave it pitted. Anyways, everything I need to refurbish the propeller has been ordered. What else? I got the new cutlass bearing, I got the new masthead tricolor, and a handful of little doodads and bit bops that has all been purchased with the unbelievably kind support of the patrons. So again, I try not to promote myself too much because, I don't know, it just kind of feels weird. But when the support of the patrons has made a tangible, noticeable difference to the project. Things have been tight, like they have been for a lot of people, and the entire conversion's been paid by you guys. Like I would have figured it out how to, one way or another, I would have figured it out without the patrons, but with the patrons, it's been so much easier, and it's been, I mean, yeah, how do I keep saying thank you? It's, it makes a difference financially, but again, more than that, it is the encouragement. It's one thing for somebody to watch, which I do absolutely appreciate, but it's another thing to say, here, I want you to keep going. It is incredibly motivating, and it also makes me feel a little bit bad when I have these gaps where I can't make videos every week like I want to. However, the current flood of work, I think, is more or less behind me. I might have another month of heavy work. But as soon as the water's in the boat, let's not do that. As soon as the boat is in the water, I have got so many things I've got ready to test. I'm going to do a whole bunch of pitch tests on the propeller. I'm going to be doing pulley ratios on the motors. I'm going to be doing the 5 kilowatt versus the 10 kilowatt, which is why getting this working was so important to me. I have a lot coming, and I hope to have a lot of content. Yeah, again, patrons, past and current, damn, thank you. Thank you so much. And to the people who watch, Google AdSense, it's not nearly as much as the Patreon, but it is something, and it helps. So even just for watching, again, I'm babbling on because I still, like, pinch me. I can't believe I've got so many people watching and helping. Okay, with that, I'm going to say thank you very much. I'm the Digital Mermaid, and can you do the usual YouTube doobly-doo thingies? I will be back as soon as I can. I'm hoping that the next video I will have the motor and the controller, and I will be building the second motor. I need to get that done so that I can design the motor mounts, which I have a plan for. I am rambling now. I will be back as soon as I can, but it might be a little bit more delayed still. Okay, bye. Editing Maddie, this is a standalone video. So one of the things I need to figure out is the new dashboard. How much space do I have? So if I left no space, what is that, 8 inches, 22 centimeters? But I want to leave some space. So if I do, actually, where is it? I don't want to bash my fingers against the wheel. If I make the new dashboard 15 centimeters, 6 inches, I could go up to, I think 18 would be cutting it too close. So using freedom units, 6 to 7 inches would be good. Because then, well, it's going to stop about here, and I want to put the throttle about here. So I'll mount it as high as I can. That'll bring this up to here. And I'll have the other throttle here for left-handed and redundancy. So yeah, I've got that depth, and then the height. I mean, I just need to be able to mount it back here. I can have it come up higher. And then I'll have one compass rose, throttle, displays wherever I want to fit them. I know how much space I have to work with now. Put the center compass, the mechanical compass right here, and have a dock for radar and a dock for navigation. I could probably even put a couple little speakers in here for some music. Oh, look at that, look at the bird.
Yeah, there's a couple of them that have been over there today.
Ah, it's adorable. Hey, little birdie. Oh, okay, fine. Screw you too. Okay, anyways, what was I saying? Yeah, so now I've got these measurements.